We will now walk through an example of using the AWS Encryption SDK to encrypt plaintext data and persist it to an S3 bucket.
I have built a sample application which will run on an application server and use client-side encryption and demonstrate the use of client-side encryption in AWS. From my AWS account, I will log into the application server to run the code. I'll use Systems Manager to log into the application server. Let's take a look at the sample application that will perform the encryption. So as you can see, the code is pretty straightforward. The application code is going to take a plain text message and make use of the AWS Encryption SDK for Python to encrypt the message. So here it's going to encrypt the plain text message, and then it's going to store the message as an object in an S3 bucket. So I'm going to use the put object call to invoke the S3 API. I also have a second application script which is going to do the opposite. It's going to decrypt the encrypted data. That's again pretty simple and straightforward. First, I'm going to get the object from S3 using the getObject call, and once I get the object, I'm going to use the AWS Encryption SDK to decrypt the object, and then I'm going to just print out the plain text content of that object. At the top of both of my applications, I've defined the S3 bucket that I'm going to use as an environment variable, and I've also defined the KMS key that I'm going to use to perform the encryption and decryption operations. So the application code is going to use an IAM role to make the API calls to the to S3 and the KMS key that's going to be used for encryption and decryption. So let's take a look at that IAM role. Let's go back to our AWS console, go to EC2, and let's take a look at the role that the instance is going to be using. So the instance is assigned an IAM role. So let's remember the name, ND063 L1 instance role. That's the role that's going to be used. So what we want to do is we want to make sure that the KMS master key that's going to be used for encryption has allowed this role to use the key. So I'm going to go to the key management service, and this is the key that I'm going to use. So let's go into this key and take a look at the key policy. So you can see that in the key users, I've only allowed this particular role to be using the key. And that's the role that my instance has been assigned. So the application code, if you recall, needed the key ID to perform its operations. So I'm going to grab the ARN. I'm going to have to define this as an environment variable in my application code. I'm going to copy this, and I have an environment variable file which this KMS key ARN is going to be defined in. And it looks like it's already defined. I've also defined the S3 bucket where the file is going to be written and read from. So I'm ready to run my application code. So this S3 bucket that I'm going to be using does not have server-side encryption or any other special security controls enabled. So I'm just going to be demonstrating client-side encryption. So before I run my application, I'm going to source my environment variables. Let's just take one look at it again. Make sure everything looks good. So I'm going to source my environment variables, and now I'm going to run the application. I'm going to pass in an arbitrary message that is going to be encrypted. All right, so the message was encrypted and stored in the S3 bucket. Let's go ahead and take a look at the contents of the S3 bucket to verify. So as you can see, a new file has been generated in S3. So now what I want to do is I'm going to download this file and verify that it's indeed encrypted. So I'm going to go back to my application server, and I'm going to download the file to the application server. So first I'll list out the contents of the S3 bucket. Okay, so now I'm going to download the file using the copy command. And I've downloaded the file. Now let's look at the contents of the file. So the original contents of the file were this message: I want this secret message to be encrypted. If it's encrypted, we shouldn't be able to see that message. And as you can see, it's a bunch of jumbled up ciphertext. So our encryption worked. The sensitive data that we had put into this file is effectively protected from other actors who may have inadvertent access to the S3 bucket. So now we can try running the decrypt application, which will grab the file from S3 and use the same KMS key to decrypt the data. So as you can see, the message was successfully decrypted. That's our original message, if you recall. If you're developing applications or need to encrypt sensitive data before it lands on disk, I advise you to investigate the use of client-side encryption as an additional safeguard. Client-side encryption in AWS can be achieved using your preferred language SDKs for AWS, or the AWS Encryption SDK, which we have used in this example, or in some cases, client-side encryption SDKs for specific services such as DynamoDB or S3, which allow you to have client-side encryption baked into the API calls for the service.